In this video, we'll be looking at lesson 3.3, function notation. Definition. Function notation is an alternative way of writing a function in which the dependent variable and by the dependent variable we often use y. We call x the independent, it's our input, y is dependent, our output. Is replaced by f of x or similar. Let's look at a couple of examples. All right, in equation notation, we might say something like y equals 3x plus 5. Well, an analogous statement in function notation would be, I would just take this y and replace with f of x. And this f is totally arbitrary. It could have been g or h or any other symbol. It is simply what we are calling our function. This is will now be referred to as the f function. All right. What is the advantage of it? We'll see a couple here in a little while, but first it'll let us distinguish between multiple ones. If I had y equals 3x plus 5, what will I call my next one? Here, if I have f of x equal 3x plus 5, the next one that's different might be g or h or smiley face, whatever symbol we want to use out here. All right. Let's say we were looking at the volume of a sphere. Well, the volume of a sphere is 4/3 pi r cubed. An analogous statement in function notation, I could say v of r. And this v, because it's volume, I put that out there. It makes sense, but again, it could have been anything. 4/3 pi r cubed. Okay. One last one. Let's say we have m is equal to 2 plus 5 times smiley face. All right. An analogous statement. I don't have to use this m as the name of the function. I can call it anything. This time I'm going to call it h. But what is important is whatever this independent variable is, it will go in the parentheses. In this case, smiley face. Okay. Is 2 plus 5 smiley face. So what we see is whatever this input, the independent variable, it's placed inside my parentheses here. R is my input, it's here. Smiley face is my input, it's here. This symbol on the outside is simply the name of the function. We're calling this the h function, this the v function, and this the f function. All right. How are we going to use this notation? So let us start with our equation notation of the first equation here, this y equals 3x plus 5. Let's say I had a scenario and I wanted, I know I have an x value of 2. I want to know what is the corresponding y value. Well, we know by now we will take this 2 and substitute it in place of x. So rewriting this equation as y equals 3 times 2 plus 5. Now I can evaluate this right side. 3 times 2 is 6. 6 plus 5. And then 6 plus 5 is 11. And we should have y here and y here. So what we see is when x is 2, y is 11. In equation notation, I would write that as an ordered pair, that 2 pairs with 11. All right. So let's look at this same situation using function notation. So I have my function f of x is 3x plus 5. All right, instead of making this statement x equal 2, y equals question mark, this becomes more efficient in my function notation. I will simply say f of 2 is equal to what it is I'm looking for now. And so I can immediately go to my substitution. Here I've let x become 2. I'm simply going to substitute 2 in here for x. So I have 3 times 2 plus 5. So 3 times 2, that's 6. 6 plus 5. And 6 plus 5 is indeed 11. All right. So I see that f of 2 is equal to 11. I'll rewrite this statement over here. So what we see is these two statements are analogous. All right. To say that when x is 2, y is 11 is the same as saying the function value at 2 is 11. When x is 2, f of x is 11. So in short, you can think of f of x as being y, right? V of r as being v, h of smiley face as being m in this case. This is the dependent quantity. As we advance in mathematics, you will see that function notation is used more frequently than equation notation. It's going to allow for some more utility. Let's take a look at some of our problems from XYZ. All right, in question 1, they're giving us two functions. F of x is 4x plus 4, and g of x is x squared plus 2x minus 1. So now you can already see some of the utility. We're going to be able to look at two functions at one time. All right, so now I can evaluate some of these functions. All right, I'm going to write my two functions down. I have f of x is 4x plus 4. And I separately have g of x is x squared plus 2x minus 1. Well, the first question says, what is f of 2? So I'm simply going to replace 2 for x in every position that we see it. All right, 4 times 2 is 8, plus 4 is 12. So here we say f of 2 is equal to 12. This is the same as saying the point 2 goes to 12. All right, moving on down, let's look at g of negative 1. So in this case, I'll take negative 1 and replace for x. Okay, so negative 1 goes in place of that x. Remember to, in general, use parentheses when you substitute, but particularly when we're squaring a negative, the parentheses is essential. 2 times negative 1 minus 1. Every place there was an x, I have substituted negative 1. All right, negative 1 quantity squared is 1. 2 times negative 1 is minus 2, and minus 1 here. So we have 1 minus 2, that is negative 1, minus 1, that is negative 2. So we say that g of negative 1 is negative 2. All right, I want to go on down and look at this very bottom one. We have substituted a minus 1. This time we are looking to to substitute more. We don't have a constant. We have an algebraic expression. We have another variable in here. All right. So again, with our function is g of x is x squared plus 2x minus 1. To say g of a minus 1, I'm going to change that to a minus 3. Perhaps yours is exactly a minus 1. I've just changed this a minus 1 to a minus 3. We're just doing an example. Here I've replaced x with a minus 3. I'm going to do that same thing over here. So I have a minus 3 quantity squared plus 2 times a minus 3 minus 1. I simply replaced the expression a minus 3 every place there's an x. There and there. Now I can simplify this right side. Remember, a minus 3 squared means a minus 3 times a minus 3 plus 2 times a minus 3 minus 1. Squaring, multiplying this out, a times a is a squared. A times minus 3 is a minus 3a. Negative 3 times a is a negative 3a. Adding is a negative 6a. Negative 3 times negative 3 is a plus 9. 2 times a is plus 2a. 2 times minus 3 is a minus 6. Minus 7. Now I can combine like terms. Nothing is like a squared. Minus 6a plus 2a is a minus 4a. And then 9 minus 6 is 3. Minus 7 is a minus 4. This is g of a minus 3. All right. Looking at question 2, very similar. Actually, that's question 2. Very similar. Question 3. Now, question 3, they're giving us some ordered pairs. This is even going to be easier. The f function is defined as this set of ordered pairs. The g function is defined as this set of ordered pairs. So it says, what is f of 3? They're simply asking us, what does 3 pair with? Well, 3 pairs with negative 2. All right. So in this case, you would say negative 2. F of 3 is negative 2. Coming on down, f of pi. Well, pi pairs with negative 1. So in this position, you would say negative 1. What is g of negative 1? Well, negative 1 pairs with negative 3. That would be negative 3 there. All right. I think you should be pretty successful on 3.3.